Hey grade 12s and welcome to the trigonometry section of the November 2024 paper 2 exam. And we're on question 5. Question 5 says in the diagram line OP is given with P being -3 and -4, and then we're given the size of KOP, well, that angle, which is equal to A. And the first question is to determine, without using a calculator, the value of cos A. Okay, so this is our typical trig diagram that we have. So we're going to draw a vertical line to the x-axis, and remember it is perpendicular to that x-axis. So where these go, remember that -3 is your x value, -4 is your y value. So where we're going to put them down is like this. So from the center to this side, you see that is an x value we're measuring. So that's going to be the x value, -3. And then if we were looking at the y value from the origin down, okay, to that, you see that? So that is the -4 that we have. Okay, so that is -4. So the only thing missing is your hypotenuse or your radius. And we can go ahead and find that using Pythagoras. So it's the radius, the longest side. So r squared is equal to, and we'll take one shorter side squared plus the other shorter side squared. Okay, so what does that give us? That's going to be 9, that's going to be 16, so 25. So r squared equals 25. And then square root both sides. You know, it's positive and negative, but a radius is a length, so it's always going to be positive. So r is equal to 5 units. And now we know what r is. We can find cos A. Okay, so since this is 5 units, then remember that cos in saw katoa, cos is the ka part. So that is adjacent over hypotenuse. So the adjacent side to that angle, that reference angle, is the -3 over the hypotenuse, which is 5. So cos A, therefore, cos A is equal to -3 over 5. And there we go. That is 2 marks. Moving on to the next question. The next question, 5.1.2, says we need to find the value of cos 2a. Okay, so cos 2a is a double angle. Just expand it to another double angle. It'll be easier to expand it to something that has just cos because you already have cos. So I'm going to go ahead and expand that to 2 cos squared a minus 1. Okay, because it'll be easier to work with. So 2, and then what is cos a? It's -3 over 5. So that's times -3 over 5. But this is squared, so you need to square that. Squared minus 1. And you can punch that into the calculator and actually just get your answer. That's fine. And we get an answer of -7 over 25. Okay, it's best to just save time. And anyways, the mark allocation is just 2 marks. So done with that. Moving on to the next question. The next question, 5.1.3, says we are given sine A minus B, right? We need to find sine A minus B if it is further given that sine B is 4 over 5 and that B is greater than 90 degrees but less than 360. Okay, so just expand this. You see that this is a compound angle. It has a compound angle expansion. So we just need to expand that. Now, you know it's going to include things like sine A, cos B, and things like that. So you just need to get the second diagram, the diagram that has B as the angle. Okay, so it's just what we didn't do there, we're going to do here. Okay, so we'll just draw down a Cartesian plane first. And you can label your angles. And do you see what they tell us here? Sine B is equal to 4 over 5. 4 over 5 is a positive number. So they're telling us the sign is positive first of all. So we're going to mark all the quadrants where we see sine being positive. So you know that this is where everything is positive. This is where sine is positive. This is tan and cos. So all the quadrants where sine is positive is in the first and the second quadrant. And then you see what they tell us about B, that B is greater than 90 degrees but less than 360 degrees. You're going to mark all the columns that are greater than 90 but less than 360. So greater than 90, this is everything greater than 90, and less than 360. So that is the second, the third, and the fourth. Okay, and then the column or the quadrant with the most ticks would be your quadrant, which is of course the second quadrant. So that is what we are going to have. Okay, we just have that in the second quadrant, and that's it. Okay, so our terminal arm goes here, and we have B. Okay, so B is always measure from 0 degrees, which is here in the first quadrant. So like that, and that is our B. Okay, so all we're really just doing is completing this diagram. Okay, so first of all, you see that they told us that sine B is equal to 4 over 5. So this also means something else. 4, remember, as saw Katoa, right? Opposite over hypotenuse. So 4 is the opposite side, H is the hypotenuse side. So we're going to drop a vertical line down to the x-axis, and this is perpendicular. And then this is our 4 over here, and the hypotenuse is 5. So it means that we need to find the adjacent side, which we can see is an x value. So we're going to find this by saying x squared. Now, because it's a shorter side, you're going to take the longest side, the hypotenuse squared, minus the other shorter side squared. And so that's x squared is equal to, okay, so 25, that's going to be 25, and that's minus 16. 25 minus 16 is 9. And then we're going to square root both hand sides, make that positive or negative. So this is x squared is equal to, now, do you see the part of the x-axis we are on? This is the negative part of the x-axis, so you need to make this negative. So x is equal to negative 3. And this is our diagram completed. Okay, so now we have everything to complete this sine A minus B. Okay, so this is sine A minus B, and then we expand this to sine A cos B minus cos A sine B. Okay, I like to remember it as sine cos sine. Okay, and I see that as the sine song, and then it's still A B A B. Okay, so now that we have this, we can actually get all of these values because both diagrams are complete. So what is sine A? Okay, so in our diagram, sine A, because this is our diagram, is opposite over hypotenuse. So this is for the angle A. It's going to be the opposite side, negative 4 over 5. So we know the value of sine A is negative 4 over 5. And this is being multiplied by cos B. And we already know what cos B here is. Well, we can find it. Cos is adjacent over hypotenuse. So that's negative 3 over 5. So put that down as well. Negative 3 over 5 minus cos A. So cos A is in the A diagram. So cos, that is adjacent over hypotenuse, negative 3 over 5, which we already had, but okay, minus negative 3 over 5, which has been multiplied by sine B, okay? So they already told us that was 4 over 5, but you can also look at it here, opposite over hypotenuse, which is 4 over 5. And this is all we have. So you just have to multiply it and get your answer. Okay, just for explanation, because sometimes, you have variables here. Just remember, when you're looking at these, right, multiplication joins terms together. You always simplify expressions term by term. So this makes one term on its own. Then you have a minus sign, which is separating the term. And then this will be your second term, okay? So if you deal with, you see the first term, you just deal with that. And then the second term, you deal with that. And then it's perfectly fine, okay? So it's equal to, this is going to give you positive 12 over 25. And then here, instead of just putting the minus immediately, what I'll look at is the fact that there's a negative bracket, a negative times a positive, okay? So it's just that negative times the positive times the negative. So do you see that this will end up becoming a positive value? So just multiply. 3 times 4 is 12 as well. So that's going to be positive 12 over 25. Okay, so we didn't need a calculator for that. And it's good to deal with these because sometimes they have variables and you can't use a calculator. So you need to know how to just work it out on your own. It's equal to, and that is 24 over 25. And that is our answer. Okay, so they are being very lenient. And we'll just see if the rest of the trig section is like that. Okay, but that is the answer to that question. And that is it for 5.1 questions. And we move on to 5.2. We are now on 5.2, and 5.2 says, if cos of alpha is equal to P, express the following in terms of P. Okay, so this is what we've been given. So do you see there is an angle being repeated here? Okay, alpha over 2 minus 45 degrees is being repeated. So what they tell us is that cos alpha is equal to P. So we're really just taking this and somehow relating it to P. Okay, so I'm just going to rewrite this first and then let's get simplifying. Okay, so this is what we have. So with this, you should already be able to spot, you see the cos, same angle, sine, same angle, okay? This comes from double angles. So you see the double angle sine 2a and how this angle is equal to, I need more space, so sine 2a is equal to 2 sine a cos a. Do you see a repetition of that sine a cos a here? Okay, sine a cos a is happening here. Okay, that's like sine a cos a because it's the same angle. Okay, so what we can actually do here is make sine a cos a the subject so that we can see what is equal to and we can replace that here. So here the 2 would be what needs to leave. So if you divide both sides by 2 to get rid of the 2, you see now that sine a cos a is going to be equal to sine 2a over 2. So we just need to understand what is our a, okay? So the sine a cos a is the same thing here. You could have just switched these around, okay, to make it easier for yourself. If you put this one in front of this one. So let's put the cos this side and the sine this side. This is still sine a cos a as well. It's in that same form. So it's going to simplify to the same way this simplified to sine 2a. It's going to simplify to sine 2 and then our angle. So this represents our a here. It's what's being repeated. Sine that angle, cos that angle. Okay, sine a cos a. Same thing. So sine 2 times our a is that alpha over 2 minus 45 degrees. Okay, so with that, right, we're allowed to write the 2 and then times that because the 2 is part of the angle. It's the coefficient of that angle, okay? It stands for double, okay? So it's going to multiply into the angle. So we have alpha over 2 and then minus 45 degrees. Okay, so this is what we have. And we can just, okay, so don't forget the 2. That's the one thing. Okay, so this one, right, that's the sine 2a over 2. So this one itself has an over 2. But remember that the main expression also has a denominator of 2. Okay, so this just stands for this part. That's our sine 2a over 2. But we still have a divided by 2. So let's not forget that. Divided by 2. Okay, we can actually sort that out. With divided by 2, you can actually just use it as a number. This is one term, and we can just say divided by 2, and then we'll tip in times. Okay, so this is equal to, we'll sort that division out. Let's simplify here. The 2 is going to multiply into the 2 terms in that angle. So sine, and we have 2 times this. Remember, this 2 cannot divide with this. This is a number 2, like a unit value of 2. This is the coefficient of an angle. They're not the same thing, so they can't cancel. And then so we have here alpha. So that's going to be alpha. And then minus, when it multiplies there, it's minus 90 degrees. Okay, and then it's still over 2 divided by 2. But here's the thing with dividing by 2. 2 as a whole number is 2 over 1. When you need to divide, what you're going to do is keep the first fraction the same, and we're going to do something called tip and times. So you're going to tip this number, and so you swap the numerator and denominator, and you change your division to a multiplication. So tip and times. Okay, so this is what we have right now. If we multiply, this times 1 stays exactly the same. So it's sine alpha minus 90 degrees, and 2 times 2 is 4. So over 4. Okay, so this is what we have. And now we have to simplify this. Okay, you see 90 degrees, you see an angle. So this screams cofunctions. But the thing about this cofunction is you see that the angle is negative. Remember how alpha represents an acute angle. So for example, like 30 degrees, right? So you have like 30 degrees minus 90 degrees, for example. And that would give you negative 60 degrees. So ultimately your entire angle here is still negative. What do you do when your angle is negative? You add 360 degrees, okay, so that it becomes positive, and we can actually simplify it better. So this is equal to, when we have sine, and when you add 360 degrees to negative 90, you get to 70 degrees plus alpha, still over 4, okay, is equal to, now the thing is, it's still cofunctions. We're still looking at it as cofunctions. However, you need to make it look like cofunctions. So we're going to separate the 90 degrees from this. So we're going to rewrite this as sine 90 degrees plus what gives you 270. That's plus 180 degrees. And then we still have our positive alpha, which was positive from the beginning, as you saw here. Okay, all over 4. Let's not forget that 4. And then what we're going to do here is we're going to group these two together so that this reads as sine 90 degrees plus an angle. Just the same way we have sine 90 degrees plus a. And you know that the cofunction for this is cos a, positive cos a, right? So the same way we are looking at this a, right, as this 180 degrees plus alpha is the same way we're going to simplify this to cos of our a. And our a is the 180 degrees plus alpha. So that's 180 degrees plus alpha all over 4. Okay, so that's what we have then. That's how you simplify that. It's 90 plus that angle. That's our a. Okay, so now that we have this, we're just going to have to simplify or reduce that. Cos 180 plus alpha. As you can see, that is not cos's quadrant. That is tan's quadrant. So that simplifies to negative cos alpha. See, we have a cos alpha now. So what did they tell us about cos alpha in the beginning? They told us that cos alpha is equal to p. So wherever we see cos alpha, we're going to replace it with p. So this means that this is finally equal to negative p over 4. And that is our answer. Okay, so that is the answer to that question, 5.2. And that is the end of question 5. Moving on to question 6. Okay, we're on question 6, and question 6 says 6.1. Given the identity cos x minus y is equal to cos x cos y plus sin x sin y, you need to use the compound angle identity given above. Okay, use this compound angle identity to derive a formula for cos x plus y. Okay, as you can see in our grade 12s, they keep bringing this proof question in. Okay, so they never really ask you to prove the entire compound angle formula, but they ask you to prove part of it, and this is a part of it. So how we're working with this is they're saying, using this idea, okay, using the fact that cos of x minus y, in other words, cos of a first angle minus a second angle, gives you cos of that first angle, cos of the second angle, okay, plus, so wherever you see that minus, you're going to change it to a plus. Okay, so plus that gives you sine of, again, the first angle, and then sine of the second angle. Okay, so that's really what they are saying. And I'm saying first angle and second angle for a reason, because you're going to have to think about it like that for you to be able to derive a formula for cos x plus y. So this is what they want you to find. Find the expansion of this using this idea. Okay, so let's rewrite what we have to expand. This is cos x plus y. Okay, so look at this. If we have to use this idea on this, what is the one thing that is a challenge right now? That would be, so you just compare them, right? You see that you have cos x, okay? That's great. But then you have a minus here and you have a plus. This needs to be a minus. So how can we change that positive to a minus? It's not just by changing it, because then you're going to change the value of it. What we're going to do is rewrite that positive. So cos x, and how do you rewrite a positive so that it includes a negative? Well, you know that a negative multiplied by a negative gives you a positive. So we're going to change that to minus, and we're changing this positive y to negative y. See, we're not changing the value, we're just changing the way it looks, because if you multiply back, it's still positive y. Okay, so now that it is in this format, cos of your first angle, okay, minus your second angle. Now that it's in that format, we're going to expand just like they did here. So we're going to expand this just like they did. Okay, so they said cos of their first angle, And we're going to also put that down. Cos of our first angle is x as well. So we're going to say cos x. And then they said cos of their second angle, which is y. But our second angle is negative y, as you can see. So we're saying cos negative y. And then because they had the minus in the middle, they changed it to a plus. We will do the same. Then sine of the first angle. So sine of our first angle is still x. Okay, so sine x. And then sine of the second angle, our second angle is negative y. Okay, and once you've got this part, all you have to do is simplify now. Okay, so we're saying this is equal to cos x. And then we have cos negative y. So when your angle is negative, what do? You add 360 degrees to it. You don't have to show them this. As long as you simplify it correctly, then it's fine. Same thing here. That angle is negative, add 360 degrees to it. So when you have cos 360 degrees minus y, what does that simplify to? Well, that is in cos quadrant, so it's going to stay positive. So that stays positive cos y. Continue, plus sine x. And when you have sine 360 degrees minus y, what does that simplify to? Well, that is in cos's quadrant, and sine is negative in cos's quadrant, so that becomes negative sine y. Okay, and all we have to do is simplify. You see, this is our first term and our second term. These two will multiply and become negative. So our answer is cos x, cos y. Those multiply and become negative. Sine x, sine y. And there is the expansion. Okay, so we do know that cos x plus y is really equal to this. And that is our answer. Okay, moving on to the next question. 6.1.2 says, hence or otherwise show that all of this is equal to tan x plus y. Okay, just take it as it is, simplify as far as you can, and you'll just see things simplify and cancel. Okay, if there's things that we need to really think about deeply, we will do so. Okay, so as you can see, the left hand side is what we are working with here, because that's actually where we have to simplify things. So we just rewrite the left hand side first. Okay, so this is what we have. Let's get simplifying. Okay, so first we have cofunctions, cos 90 degrees minus x, and that gives you positive sine x. Okay, and then we have cos y, which is just cos y. Then we have sine negative y. You know now that that simplifies to negative sine y. Okay, so it is really just a negative. You can change it from there. It's fine already because it's like it multiplies. Okay, negative sine y. And then cos 180 degrees plus x, that is not in cos's quadrant. That's in tan's quadrant. So it gets reduced to negative. Okay, so it's being multiplied by negative cos x. Okay, and then we'll multiply that. And this goes all over and we have cos x and then 360 degrees plus y. Okay, so this is the one that they like to trick you with a lot. When the angle, okay, remember that y represents an acute angle. So right now you have 360 degrees plus an acute angle. So the angle ultimately is going to be over 360 degrees. You need it to be within 0 to 360 degrees. So you would subtract 360 degrees from it. If you minus 360 degrees from that, that just gives you cos y. Simple. Done, okay? Because that was a plus. And then we have sine 360 degrees minus x. You can see that one is a reduction. 360 degrees minus x, that lies in the fourth quadrant. And sine is negative in that quadrant. So that simplifies to negative sine x. And then we still have times sine y. Okay, I don't want to be doing the whole thing like positive. Oh, okay, then it becomes negative sine because we're still going to multiply at the end of the day. So it's fine. You can just change it from there. So it's equal to, and we're just going to simplify. Okay, so on the numerator, we just have sine x, cos y, and negative times negative is positive. Okay, so that becomes positive sine y cos x. You just have to remember that this is separating, okay, those two terms. Over, and on the denominator you see that we have cos x cos y minus sin x sin y. Okay, they're being very lenient here. Okay, so you see with the numerator using cofunctions, that simplifies to sin x plus y. okay, all over, and using that denominator, and that's probably why they said hence or otherwise. Okay, so you see how that was that cofunction, okay, cos x plus y. That simplifies to cos x plus y, because that is the cos rule, the cos song, really. And now because they are both exactly the same, it's like having sine A over cos A. You know that that's going to be equal to tan A. So like that, that's going to be equal to tan x plus y, okay, which is equal to the right-hand side. So we can just tell them it is equal to the right-hand side. So at the end of the day, the left-hand side really is equal to the right-hand side. Okay, moving on to the next question. The next question is 6.2. Let me just make space. The next question, 6.2, says, given f of x is equal to, and we have the square root of 6 sine squared x. Okay. So we have this. Don't get afraid because you see square root, it's fine. They just say solve for x in the interval where x is an element of 0 degrees to 360 degrees. Very simple interval, okay? If f of x is equal to 2. Okay, so let's just make f of x equal to 2. That's all we have to do. So I'm already going to straight away say f of x is equal to 2, so I'll replace that there. 2 is equal to, and we have the square root of 6 sine squared x minus 11 cos 90 degrees plus x plus 7. Okay, so yeah, it looks like it's going to become a trinomial. So let's just simplify like the way we're supposed to. First of all, we've got a square root. It's not nice to work with square roots because then you can't really get into what is inside there. So we're going to get rid of the square root by squaring both sides. So square that and square that. So that gives you 4 is equal to, and now the root is gone. And you now have, and we're just going to take advantage and start simplifying. So 6 sine squared x minus 11. Now you see a cofunction here. What does that simplify to? So remember, that's the cos 90 plus. That's the one that becomes negative. So that becomes negative sine x. Okay, and then plus 7. Simplify again. We can take that 4 over. So we have a 0 is equal to 6 sine squared x. That becomes positive 11 sine x. And then 7 minus 4 gives you, because the 4 comes over, gives you positive 3. And yes, we have a trinomial. You see that this is sine squared x and then sine x and then a constant. Just like you could actually, if you wanted to factorize this properly without getting too intimidated by the sine x, you can replace sine x with k. So you're just going to call it 6k squared. You don't have to tell them this. You can just do it on the side. So plus 11k plus 3 and then factorize this. Okay, grade 12s, I have a video on factorization. You can use that. You can also use the factor method. That's also fine. But I'm just going to use the cross method here because I think it's quicker. So factors of 6k squared, that's going to be, I'll separate it, 3k times 2k, okay? And then factors of 3 is the prime number, so it's really simple. You can put it as 3 and 1, but you need to check if it's going to work out. So like this as 3 and 1, that's going to be 3k, and that's going to be 6k. I don't see that ever creating 11. So I'm going to rewrite that 3 as 1 and 3. Okay, and it's all positive throughout, so all factors are positive. Now let's test out if it really does give us the middle coefficient. So 3k times 3 is 9k, and 2k times 1 is positive 2k, which is indeed 11k. So that works out perfectly. So you see how this is going to simplify to 3k plus 1 multiplied by k plus 3. The same way with the sine, it's going to simplify to, so we have 0 is equal to, and we have 3. Now remember our k is our sine x. So that's 3 times sine x plus 1, and then multiply by sine x plus 3. And those are your factors. Done. Okay, so just do that on the side. And so since we have this, now we can finally just solve for x. So something multiplied by something equals 0 is either the first thing is equal to 0 or the second thing is equal to 0. So let's simplify. If you take the 1 over, we just have 3 sine x is equal to negative 1, and then you will divide both sides by 3, which leaves you with sine x being equal to negative 1 over 3. Okay, here we would have sine x is equal to negative 3. Okay, so what do they want us to do again? They want us to solve for x, okay, within that interval. So let's solve for x. You need to first find the general solution before you can find specific solutions. So let's find the general solution of this. So you can use that method where you use the quadrants and you ask yourself, where is sine negative? And then you use those reductions. You can do that. Or you can use this method that I'm using, which I showed in this video. So you can watch that video to learn this method if it confuses you. But you can also use your method. You will get to the same answer. So first of all, I'm going to find the reference angle. Okay, and I'll just do that by taking sine over, or really just the second function of sine. So shift sine negative 1 over 3, and I still use it as negative. That's why I use this method, because I don't have to consider whether something is negative or positive. Okay, so the reference angle is just negative 19.47 degrees, and I'll just round it off right now because this is not saying 2x or anything like that. I don't have to divide or multiply at the end of the day, so I'll round off already. Okay, so negative 19.47 degrees, and we just need to find the general solution of this. What you're first going to do is say x is equal to, and you're going to put down your reference angle, which is negative 19.47 degrees, and then you say plus k of 360 degrees, because the sine graph repeats itself every 360 degrees, okay? Or the next x value that we have is where we have 180 degrees minus our reference angle. Our reference angle is negative 19 point that. So negative times negative becomes positive. So it's positive 19.47 degrees plus k 360 degrees, where k is an element of integers. Okay, we're going to find the specific solutions now. Now, so that my answer looks like yours, what I'm going to do here is I'm going to add 360 degrees because my angle is just negative. Now I can just make it look positive. So if you work through this using the method where you ask yourself which quadrants is sine negative in, this is probably the answer you're going to get. When I add 360 degrees to that, okay, so if you take this and you add 360 degrees, you see that you're going to get, and this probably looks like your answer now. So 340.53 degrees. Okay, that's our answer there. Or here, x is equal to, sorry, I keep forgetting, plus k 360 degrees. Okay, or, and then we have, I don't have to rewrite that again, is equal to, and then just add that angle, right? Add that to 180 degrees. So, okay, we can just say 180 minus that angle. And that becomes, as you can see, 199.47 degrees. Okay, plus k 360 degrees. And now they want us to specifically find answers within this interval, which is a very simple interval. Okay, so we don't have to go too far. So k is an element of integers, meaning you can only substitute integer values for k. So you can try integer values like number line values. Now there are values that are obviously not going to work here. Okay, you should already be able to spot them so that you can save more time. So I'm already going to start by saying the only integer value that is going to work is 0. Okay, 0 will work, everything else will not work. Okay, negative 1 will not work, positive 1 will not work, 2 obviously, and negative 2 will not work. You can test it out for yourself because it's just going to make it too big, and then it's not going to be within 0 degrees to 360 degrees. It must be greater than 0 but less than 360. Okay, so if you substitute 0 into the first one, that's just going to become 0 and your x value will stay exactly that. Okay, so x will be equal to 340.53 degrees, or x would be equal to, if you substitute 0, that becomes 0, so 119.47 degrees. You can try substituting other values and you'll see that it's not going to work. It's going to either make it negative or over 360. Okay, so those are our answers, and those are the specific solution to this. Okay, grade 12s, while editing, I noticed that I completely neglected this. Now, remember how this is supposed to actually be 2, sine x is equal to negative 3, and then we'll divide both sides by 2. And then this is sine x equals negative 3 over 2. The thing about this is this equation doesn't really have any solutions, and it's because of the way the sine graph goes. You see, with the sine graph, it's a graph where it's just sine of x, right? You can see that the coefficient of sine x here is 1, meaning the highest point that the sine graph is going to reach is 1. It's going to go like that and like that. The lowest point it will reach is negative 1. Because of that, a number like negative 3 over 2 will not lie on this graph. This number is really negative 1.5. Okay, it's not going to lie on this. Since the lowest it can go is negative 1, it will not go anything beyond negative 1. And so because of that, this does not have any solutions here. So x has no solutions. Okay, so that is what I should have said over there. So moving on to the next question. Okay, the next question, 6.3, says, consider the function g of x is equal to 4 minus 8 sine squared x over 3. Okay, so it looks like the expansion for it. So 6.3.1 says, calculate the maximum value of g. Okay, so all you have to look at this like is, this is a single trig function. Okay, you know how we have like sine x, cos x. Okay, it's a single trig function. It just looks funny right now. We just have to simplify it further, and then we'll be able to see that. So step 1, let's simplify that. Okay, so let's take that and simplify it. So g of x is equal to 4 minus 8 sine squared x over 3. Do you see that the numerator has 2 terms? And in those 2 terms, we have a common factor. So you can take out your common factor. The common factor is 4. So take 4 out as a common factor. And what you have left in the first term? You have 1. And then what you have left in the next term? It's minus 2 sine squared x. Okay, do you see the double angle now? 1 minus 2 sine squared x, okay, is a double angle expansion for cos 2a. Okay, that's 1 minus 2 sine squared a. So that's going to change to, we say this is equal to 4 multiplied by, and then that becomes cos 2x. It's really just multiplied, so like that, over 3. So what we just have here is 4 over 3 cos 2x. That's what g of x is, okay? And all they want us to find is the maximum value. So you can do that by simply seeing what this looks like. Okay, it's a very simple trig function. It's not shifted up or down or left or right or anything like that. If it's left or right, it's still fine. But it's not shifted up or down. So however this looks, okay, we can see that they have tampered with the period of it, okay? So it's not going to go like to 360 like that, okay? It's going to be more narrow. But regardless of that, what's happening is you have a coefficient of 4 over 3. Okay, an amplitude of 4 over 3. So it means that the highest it will go is 4 over 3, and the lowest it will go is negative 4 over 3. And then it'll do that, like the normal cos graph that it is. So what is the maximum value? The maximum value, or the highest value, is 4 over 3. And that will be our answer. So we'll just tell them the maximum value is 4 over 3. And that is it for that question. Okay, moving on to 6.3.2. which says, okay, 1 mark, I already see. It shouldn't be complicated, let's hope. They say, write down the smallest possible value of x for which g will have a maximum value in the interval this. Okay, translation. They're really just saying, what is the smallest possible value of x, okay, where this g will have a maximum value. We know where g has a maximum value. We know the maximum value of g. We don't know where yet. Okay, so the maximum is here at 4 over 3. This will not happen at one place. It will happen in multiple places. You see here where I just drew a single cos graph, okay? So one cycle of the cos graph. You see that it appears here. Here's a maximum. Here's another maximum, okay? So just in a single cycle, we're seeing this happening in 2 places. But we need to actually draw it according to, Yeah, the interval that they give us. Okay, so think about it like this. You don't have to draw the full graph like to make it pretty or anything like that. You just have to understand how that graph looks. So you know that the normal cos graph, right? Normal cos graph would have just, if it was going from 0 to 360 degrees, right? Normal cos graph would have just done this, like I drew this, like down and then back up, done. Okay, at 360 degrees, and it will be done. But the thing about this cos graph is that its period has been tampered with. We put a 2 in front of x, meaning the graph, right? It used to complete one cycle in 360 degrees. But because there's a 2 here, how you find out the amount of degrees it completes a cycle in is by saying the old period divided by the number that we have there. See how they're making you find the period without actually asking you for it, which is 180 degrees. Okay, so now you know that this new graph is going to complete this. You see how that looks up, down, up. It's going to complete that within 180 degrees. Okay, so in a graph where we're drawing from 0 to 360 degrees, what is that going to look like? It means that from 0 to 180 degrees, you're going to have a cos graph. So you're going to have one cos graph. Again, from 180 degrees to 360 degrees, because that is a length of 180 degrees again, you're going to have another cos graph like that. So that's basically what's going to happen. Okay, and again, yes, the maximum is 4/3, minimum is -4/3. That's what's going to happen. So the question is, we need to find the smallest possible value of x. I don't even see a reason for drawing all of this. It's really unnecessary. The answer is very simple. It's actually something that you'll just see straight away. Okay, the smallest possible value for x, where you're going to have that maximum. Where does this maximum appear? Here. Okay, first place it appears at what degrees? 0 degrees. You can already see that's the smallest. Okay, the other places it appears is going to be here at 180 degrees. That's that maximum again. And lastly at 360 degrees. Okay, now I'm thinking about it again. The 0, it looks like 0, but if you look at what they're saying here, let's look at this. Yeah, almost caught me there. So you see, you need to interpret this the way they spoke about it. They said x is an element of 0 degrees to 360 degrees, but they put a round bracket here. Round bracket means not including 0 degrees. So they're really saying x is greater than 0 degrees, but not equal to 0 degrees. So 0 degrees itself is not part of our interval. Okay, and then it goes to 360. So it's less than. Now look at the bracket they use here, a square bracket. So less than or equal to 360 degrees. So within this interval, because 0 degrees as an actual exact point, right, as an actual x value is not included here. The smallest one after 0 would be what? The smallest value that we have after 0. It would be 180 degrees. So the smallest x value, as they asked for, the smallest possible x value for which g will have a maximum value in this interval would be 180 degrees. Okay, so x is equal to 180 degrees. It would have been 0, but 0 is not specifically included. Values greater than 0 are included, yes, but not 0 degrees exactly. Okay, so that is the answer to that question. Moving on to the next question. Okay, question 7. Question 7 says, in the diagram below, the graph g of x is equal to tan x is drawn for the interval where x is going from -180 to +180 degrees. Okay, we need to write down the equation of the asymptote of f in the interval where x is going from 0 to 180 degrees. Okay, so the asymptote is showing right there. Okay, so from 0 to 180 degrees, what is the asymptote we have there? We have an asymptote of 90 degrees. Remember, an asymptote, okay, because it's a vertical line, just like, the asymptotes you have in hyperbolas, the vertical ones, they start with x is equal to. So the equation of this asymptote would be x is equal to, and it passes 90 degrees, okay, within that interval. So x is equal to 90 degrees is our answer there. Moving on to 7.2. 7.2 says, write down the values of x in the interval where we have x going from -180 to 0 degrees, for which f of x is less than or equal to 0. Okay, so from negative 180 to 0 within this interval, where is this graph less than or equal to 0? Where does it have a y value less than or equal to 0? So here it has y values greater than 0. Over here, do you see that all of these have y values less than 0? So less than or equal to, so we also need to include 0 here as well. So do you see that this goes from negative 90 degrees all the way to 0 degrees? Okay, so how we can write that is, it's not going to be exactly at negative 90 degrees because we have an asymptote there, but it is going to be at exactly 0 as well. So it's all of these values greater than negative 90, but less than or equal to 0. So we can, there's two ways of writing it. You can write it in set builder and interval notation. So x is greater than negative 90 degrees, but less than or equal to 0 degrees. Okay, like that. Or you can write it like this. You can say that x is an element of, and it's going from negative 90 degrees all the way to 0 degrees. But now the type of brackets you use are important. Because it's just less than negative 90 but not equal to negative 90, you use a round bracket. And here, because it is equal to 0, you use a square bracket. And that would be our answer. Okay, so two different ways of writing it. Moving on to the next question. Okay, the next question says, given g of x is equal to cos 2x plus 1. Okay, it's a simple looking graph, 2x then plus 1. So it just shifts up. The first question is, write the period of the g. Okay, we spoke about period in the 7.2 questions. The period is where you see that this graph's angles have been tampered with. Okay, has it been made wider or more narrow? And we can see that by the coefficient of x. So you see there's a 2 there. You're just going to take the old period of the graph. The cos graph, the old period is 360 degrees because the cos graph repeats every 360 degrees. And then you just divide it by the number that you see there, 2. So the period of this graph is 180 degrees. Okay, so that is our answer, 180 degrees. Okay, 7.2.3 says, on the grid given in the answer book, draw the graph of g of x. Okay, so draw the graph of g for the interval. Okay, clearly show the intercepts with the axes as well as the coordinates of the turning points. Okay, so let's just remember to also just put those points down, intercepts and turning points. Okay, so I don't really know what the answer book looked like, but we can draw it on here since this goes from negative 180 to 180, and they're probably going to just give us a situation where we have to compare these graphs. So do something when both of them are there. Okay, so let's go ahead and draw this graph. So it's this graph, we've already drawn it, kind of. Okay, you see how that went? That was that cos 2x. Just this one had a coefficient of 4/3. So you can already see how this one would be drawn. Okay, so this goes from negative 180 to 180, right? Because the period is now 180 degrees, the cos graph is going to complete one cycle every 180 degrees. So within 180 degrees, you will see one cycle. But you just need to remember here, you see what is in front of cos? It's an invisible one. So here, the coefficient, okay, or the coefficient of cos, yes, is 1, meaning the highest point is 1, the lowest point will be negative 1. So your graph is just going to look like this, okay? At 1, it's going to start like the way the cos graph goes, like that. And it's just going to complete a cycle. But we just need to make sure to draw it decently. It doesn't have to be perfect, but at least, readable. Okay, so let's just see where things would happen. First of all, naturally, you would have had at 0 degrees, your cos graph will start at 1. Okay, then at 90 degrees, it was supposed to be at 0. But because that period has been changed, okay, it's now 180 degrees, everything gets divided by 2. Okay, so it would have ended at 360, but it's ending at 180 now. So what's going to happen is what should have happened at 90, you see where this should have been at 0 at 90, it's not going to happen at 90 anymore. It's going to happen at half of 90, which is 45 degrees, which is going to be here. Okay, so that's what we'll put down there. So really the easy way to do this is just cut everything, okay, because It's really just like the normal cos graph. Just everything is going to happen at half the degrees it was supposed to happen. So cut everything in half. This is 45 degrees. This is 90. And then cut that also in half. Okay. So this was supposed to be 270's angle, right? Like this one was supposed to be 360's. Okay, but it divided by 2 and now it's 180. So 270 divided by 2, that's going to be your 135. Okay, so that's really all we can just do there. Okay, so it goes from 1, 0, then at 90 degrees, it's going to be at -1, and then at 3, 135 is going to be at 0, and then at 180 degrees, it's going to go back at 1. And that's going to be our graph. We'll just draw it out. Same thing on this side, okay? So you're going to have your -45 degrees here. You have your -90 and your -135 degrees. Okay, so then we'll just put everything down as well. So it's going to be, it's just like a zigzag pattern. Okay, 1, 0, -1, 0, 1. Same thing. So 1, 0, -1, 0, and 1. Okay, back there at 1. And now we're just going to draw it and make sure that it's curved and all. And there we go, okay? So that's the cos 2x part. Remember that the graph of G is cos 2x plus 1. Okay, so imagining what that looks like, you would actually just use a pencil. Then you know that this is going to shift up by 1 unit because we have plus 1 at the end. So that is a y value shift up really. Okay, it's moving up by 1 unit. So instead of the maximum being 1, it's now going to be 2. And the minimum is not going to be -1, it's going to be 0. So from this, it just shifts 1 unit up and looks like that. Okay, so let's just point out the things they told us to point out. They said clearly show the intercept with the axes and then the turning points. Okay, so let's tackle all the intercepts. So the intercepts that we're going to have, we know where it intersects the x-axis here. Okay, so we're going to tell them this happens at the x value of 90 degrees and the y value of 0. This one happens, that x-intercept is going to be at -90 degrees and y value of 0. And then the y-intercept, you see that the y-intercept, okay, where that maximum was going to be, is now at 0 degrees and 2. So we've pointed that out. Okay, I just changed it to red so we can see it better. And then the turning point, which we've kind of already pointed out. Okay, this is a turning point, another turning point, another turning point. The only ones you can actually just mention are the 180s and the -180. Also just point that out because it will be a turning point as well. So -180 degrees and the y value here would be 2. Okay, that's the highest, 2. And then again here, that's +180 degrees and 2. And there is our graph, okay? Not really missing anything. That is it. Okay, so that is it for that question. Moving on to the next question. The next question and the last question for question 7 says, use the graphs to determine the general solution of 2 cos. Okay, here's the thing. They will never introduce a brand new graph. That is one thing. Okay, they're not going to just at last minute just bring a new graph. So it probably has something to do with this. Okay, but let's just take that down and see how we can simplify that further. So we have 2 cos cubed x minus sine x is equal to 0. Okay, so looking at this straight away, I'm already seeing that first of all, it's very good that we have single angles here, okay? It's not saying 2x or, 3x or anything like that. It's saying x. So it means that because you have a sine and you have a cos, we can probably create tan. Okay, so why is it important to create tan? Because above the two graphs we have is cos 2x plus 1, and we have the tan of x graph as well, like they mentioned in the beginning. F of x equals tan x. That's the graph that we have here, this tan graph. Okay, so how about we try to create tan and then the other graph will kind of like form itself, or we'll manipulate it so that we can actually get that, because it's definitely those two graphs, or one of it at least. So let's go. We have 2 cos cubed x, and then we can take that over so that we can form tan is equal to sine x. Now, you know that tan is formed by saying sine x over cos x. So we are going to have to divide both hand sides by cos. So just to form that tan, I'm trying to get that f of x graph. Okay, so this gives us tan x, and here this was cos cubed x. Okay, so divided by a cos x is going to be 2 cos squared x. Okay, this is looking good. Now, so we have tan x, we have f of x, good, but we have 2 cos squared x. That's not this graph. This is cos 2x. Okay, so let's try to manipulate this so that it can look like that. What is missing? Cos 2x. We know an identity, right? For this, that has a 2 cos squared x. It's the one 2 cos squared x minus 1. So you see the difference? To get this to be 2x, we have a minus 1. So we need it to be 2x so that it can relate to g, because that's probably what they want you to do here. So let us subtract 1 on both sides so that we can have that situation, and we can change this to cos 2x. Okay, so let's say it's equal to, and I'm going to say minus 1, minus 1. And so this now becomes cos 2x, okay, because that is the double angle expansion really for cos 2x, is equal to tan x, minus 1. This is actually starting to work out now. Remember how g is this, cos 2x plus 1. So what happens when you take that negative 1 over? It becomes cos 2x plus 1 is equal to tan x. There we go. That's what they're actually speaking about. So the general solution they want us to find is use the graphs to determine the general solution for this, which is this, right? The general solution for where these two graphs are equal. What are the general solutions, or really, when these two graphs are equal, what are the x values at which they are equal? And you just have to give your answer as a general solution, not specific solutions. Okay, so they're really just asking us, where is g of x equal to f of x? Okay, drawing these graphs like this would help us see the places they are equal. So where the graphs are equal is where they intersect. So where do they intersect? Okay, first point of intersection here. Yeah, I can see it's negative 135 degrees, but we won't assume, don't worry. We'll still verify to check whether it's true or not, okay? And then here at 45 degrees, okay? That's the only place that these two graphs actually intersect, here and here. Now, because they already deliberately point out 45 degrees and negative 135 degrees from the way we constructed this, I'm just going to go ahead and test it out like that. So let's try first of all, right, where x is equal to negative 135 degrees. Does this make these two equations equal? So cos 2, and if we replace this with negative 135 degrees, okay, will it be equal to the tan of x? So tan also negative 135 degrees. If it is equal, then you know, yes, that is a point of intersection. I'm just double checking, okay? Okay, so if we say tan negative 135 is 1, then, oh yeah, that makes sense. Okay, so if you say cos 2 times negative 135, that gives you 0. Then if you say plus 1, it also gives you 1. 0 plus 1. Sorry, bracket plus 1. There we go. Okay, so it really is equal. 1 is equal to 1. So this is a point of intersection, definitely. The other point of intersection we got was at 45 degrees. You can also do this here. Now, with the 45 degrees one, I think it's relatively simple, because we know here 2 times 45 degrees is 90. Cos 90 is 0 plus 1 is 1. Tan 45 degrees is 1. So this is also going to work out. See, if you change that to 45, it gives you 1. And you know that tan 45 is 1. So x equals 45 degrees is also a solution. Okay, so you would test that out on your calculator. You wouldn't need to write it down. I just wrote it down so that we can see what's going on. But how do you represent these as a general solution? Okay, we know the answers already. It's x equals negative 135 degrees. Okay, or I guess we can leave it negative, it's fine. X equals 45 degrees. We can leave it negative because they specifically said you need to use the graphs to determine the general solution. Okay, so they know that that solution will come about because of that graph. You're going to have to add k of something. Now, depending on what your graphs look like, you'd be able to add k of whatever we're supposed to add. These two graphs, let's think about how they repeat, okay? How many degrees do they repeat in? The cos 2x plus 1, because that 2 is now there, the new period is 180 degrees, meaning this graph will repeat itself every 180 degrees. The tan x, the tan graph always repeats itself every 180 degrees. So do you see that both graphs repeat every 180 degrees? So your answer here would be x is equal to negative 135 plus k of 180 degrees. Or x is equal to 45 plus k of 180 degrees. They both repeat every 180 degrees, where k is an element of integers. And that's our answer. Okay, so that is it for that question. And we move on to 2 and 3D trigonometry in question 8. Okay, question 8 says, in the diagram, C is the foot of a vertical building. And yeah, let's just read this looking at the diagram. So C is the foot of a vertical building and D is the top of the same building. Okay, so the height of the building, CD, is 16 meters. Okay, so that's CD's length. Then they tell us that two observers are standing 19 meters apart at points A and B, okay, where A, B, and C lie in the same horizontal plane. So this is like the flat ground. These two are there, okay, C is on the same ground as them. It's just further away from them. And then we have a painter is working at the top, E. The painter's over here on the building. The angle of elevation of D from A is 46.85 degrees. Okay, the angle of elevation is over there like that. And then we have DEB is 122 degrees and BCA, okay, so DBE 122 there. And then BCA is just 105. Okay, so they've given us everything. And they want us to first of all calculate the length of AC, which is the distance between the observer A and the foot of the building. Okay, they just want you to find AC, that's all. So how would we find AC? So you're going to look at the triangles that can help you find AC. You see that you have the bottom triangle, but do you have enough information here to help you? Not really. Okay, this is not a 90-degree angle. All you have is an angle and the side opposite it. That's it. So now we can look at the second triangle, okay, where we have AC being a part of, which is this one. Okay, so this triangle, you have an angle. It's a 90-degree triangle. Great. And you have the length of CD. So that is more than enough information. We can use trig functions to find this. So how we use trig functions is you first identify the acute angle. The acute angle is this. So everything is going to be in reference to the acute angle. The side we're looking for is AC. Do you see that that is adjacent? Okay, is the adjacent side. So that acute angle is next to it. And then you're going to look at what side we have. Okay, so the side you are given to find versus the side you have. So the side we have is right opposite, okay, which is CD. So you have an opposite and an adjacent side. What function are you going to use? You're going to use tan. So I'm going to say tan of the angle that we have, 46.85 degrees, is equal to, and you know that tan is TOA, so opposite over adjacent. So that's going to be that 16 over the adjacent side, which is what we're looking for, AC. Okay, and we're just going to make AC the subject of the formula. That's all. Let's make AC the subject. So you can do so by cross multiply and multiplying both sides by AC. Okay, if you cross multiply, that just gives you AC tan 46 point. We don't have to do it like this. We can actually just transpose things, but it's fine. Okay, and 1 times 16, which is 16. And then to get AC on its own, you have to get rid of this tan 46.85. So you do that by dividing both sides by that angle. And once you do that, AC is simply just going to be equal to 16 over tan 46.85 degrees. And you would just have to find that answer. Okay, so let's just find that. And you see here, if we were trying to round off to 2 decimals, that 8 rounds up and becomes 1. That 9 becomes a 1, adds to the next 9, and that will add to the first digit. So AC is 15 units. Okay, I'll just say it here. AC is equal to 15 units because of the roundings. Okay, and that's our answer there. So that's 8.1. Moving on to 8.2. The last question for trigonometry. Okay, this paper has been relatively, well, the trig section, other sections also were fine. This paper has been, they were being really nice here, to be honest, because I know that there are November papers that were not like this. Okay, so that's a good thing. You guys just make sure you keep practicing with other exam papers as well. It's going to be very helpful. First, learn the concepts, learn everything on your own, really. Don't always wait for your teacher to teach it to you before you learn it. If you have access to a textbook, even online textbooks, learn the work first and then immediately start working on past exam papers, because that's where most of the work is really. Okay, those are the type of questions they will ask you in an exam setting. Okay, 8.2. Calculate how far the painter at E is from the top of the building. How far painter E is from the top of the building. So they just want you to find the length of ED. That's really what they want you to find. Okay, how far the painter is from the top of the building. Okay, how do we find the length of ED? Well, the only way we can find ED right now, because we know what DC is, okay? That's 16 units. We can only find ED if we find out what EC is. Okay, so this is that whole Euclid thing. To find this, you must find that. To find that, you must find that. But you must not lose track or focus of what your final goal was. So let's look at this. How can we find EC? Okay, now already you know you can't use this. We're just going to have to remember that this is 15 units. Now, how can we use everything we know and what we found here to find EC? So there are two triangles, well, one triangle that EC is a part of. It's this, right? It's a 90-degree triangle, which is great. And there's something else they told us about that triangle. You see that they're giving you this angle over here. If this is 122 degrees, if you tilt your head this way, do you see that this is an exterior angle? Okay, the exterior angle of a triangle is equal to the sum of the opposite interior angles. But we're not just going to start finding things. We need a reason to find it. Okay, don't just start finding random things. That is one way to get lost within, these numbers. So to find this, the easiest way to find EC, okay, is because this is a right angle triangle, we can use trig functions. But here's the thing we would need to know. To use trig functions, or even the sine rule, well, trig functions really, the things we would need to know are the following. You would just need at least one angle and one available side, and you'd be able to find this. So the easiest angle here would be, we'd use this angle, the acute angle. Obviously, that's the angle you have to use if you're using trig functions. So you can relate it to EC, and then we need one available side. So I guess the side we can focus on finding can be AC. Okay. If you have this angle and you have AC and you need to find EC, you can just use trig, okay, trig functions like we did here. We had this angle, we had that side, we needed to find AC. And we were able to find that. Okay, I notice I called that side AC. It's BC that we need to find. Okay, how can we find BC? Let's look at this. The only triangle that can help us to find BC right now is this bottom triangle. So let us look for a way to find BC using this bottom triangle. Okay, so how do we find BC in this triangle? ABC. Okay, so with ABC, we can use, you see that they gave us an angle and a side opposite the angle. Okay, that is already hinting sine rule. Okay, it could also be cos rule, but honestly speaking, I just try to avoid using the cos rule. I don't like the way the formula looks. It's necessary, yes, but if we can avoid it, I just try to avoid it. Okay, the sine rule is just easier to work with. So with that, because we have this and the side opposite it, in order to find BC, what we would need is we would need the angle A. If we have the angle A, right, BC is the side opposite the angle A, this angle in this bottom triangle. Okay. Okay, so we've now jumped to finding BC to finding angle A. How can we find angle A there? The only way to find angle A is if we know, because we don't have much information here. We just have this and, we have 15 units here. Okay, we can use this to our advantage. We can find angle B, this angle. If we find angle B, we can use the sine rule to help us to find angle B because we have the side opposite it. It's 15 units here. We have angle C and the side opposite it. So let's find angle B. Then using the sum of angles in the triangle, find angle A. Then use that to find BC. At that point, we can even use the cos rule if we want. Okay. And then finally, we can use that to find EC. And if we find EC, we can find DE. Okay, so it's just the whole road. That's why it's 7 marks. Makes sense. Okay, let's start. First thing we need to find is angle B. So how do we find angle B? We need to find an angle. We're using the sine rule. So in this triangle, because this is missing and we have the side opposite it, you're focusing on finding an angle. So put the sine of that angle first. So sine angle, I shouldn't call it angle B, it's not really angle B, it's angle ABC. Okay, let's be specific. ABC, right? Over, and the side is 15, is equal to, and then we are saying, here we are using these two, okay, this angle and this side. So we need to say sine 105.61 degrees over the side is 19. Okay, so let's just write this down and first find that angle ABC. Okay, so we wrote that down and now we need to get rid of the 15 to get that, okay, as a subject. So you'd multiply both sides by 15. And so sine ABC would be equal to, when you multiply, that 15 goes to the numerator. So it's sine 105.61 degrees over 19, okay? And then to find that angle, you're going to use the second function of sine, really. Okay, so this is equal to shift sine or arc sine, and you're going to say 15 sine 105.61 degrees all over 19. Okay. How about I just leave it like that? I don't like to round off. I'm going to leave it like that for now, but I will just get like an angle just so that we can see what it is. Okay, so that angle is roughly, rounds up. Okay, so it's 49.50 degrees. Okay, 49.50 degrees roughly, but I'm also just going to remember that I have that. Okay, so now that we found this, right, it's just to put it here so that we know what it is. And about 49.50 degrees, check. What do we have to find in order to be able to get the value of BC? We would have to find this angle over here, and you can just use the sum of interior angles in a triangle to do that. So it's this angle BAC. So BAC is equal to 180 degrees minus 105.61 degrees minus 49.50 degrees. Okay, so just get that answer. And there we have our answer. Okay, so I just said minus ounce. Doesn't really matter, but it's fine. 24.89. I'm just going to keep holding on to that ounce button. Okay, so that's what we have for BAC. Okay, we'll hold on to that and let's just see. Now that we know that angle, we'll just put down, a value for it. What do we have to find next? Remember, the end goal is DE. So to find EC, we need one extra side, one additional side in this triangle over here. So let's go ahead and find BC. So we can use the sine rule to find BC. We're going to take this angle, okay, with this side, because it's the side we're looking for. And then you can take one that is already available. This angle with this side. Okay, let's go. So still going to write down what we're doing here. We are trying to focus on finding the side BC. So let's make the side the subject. So we'll put that as the numerator. BC this time over, and the angle that is paired with it is, I'm going to say sine 24.89 degrees. Okay, and that is equal to, and then again it's side over the angle this time. So sine of that angle, 19, and then sine 105.61 degrees. And then we will solve for BC. Okay, so this is what we have. And remember that we already have a recorded answer for this. But now look at what we're going to do. We're going to say to get rid of, or to leave BC on its own, you need to get rid of this. So you would multiply both sides by this number, sine 24.89 degrees. Now, because you're doing that, what happens is that's going to go to the numerator here. Of course, it will cancel here because if you multiply by it, it's going to cancel numerator and denominator. So it's going to go here. So it's going to be 19 sine that. Okay, so BC is therefore equal to 19 sine 24.89 degrees. Remember, we already have an answer we're holding on to for that, over sine 105.61 degrees. Okay, let's find BC. So in our calculator, I'll be very careful with this. You guys can just use that ans button. Okay, I have to press equal to first. And then I'm going to put down my answer here. So it's a fraction and I'm saying 19 sine, and instead of saying 24 point that, I'm just going to say ans, okay, so that it uses that, over sine of 105.61 degrees. Okay, my calculator has to load now because the number is really long, okay? Okay, so that is 8.30. Okay, I'm just still leaving it like that, but I'm still holding on to that ans. Okay, let's hold on to that. We got BC. Okay, let's just remove all the things that we don't really need right now. So the angles we have, and now we have BC. So BC. Okay, we have this as 8.30. Okay, and that is in meters. Now we have to use that to find EC. So you're going to use trig functions here because this is a right angle triangle. So it's easier to use trig functions here. So the angle that you have, okay, and that's where we need to find this angle. The angle that we're going to have here is this acute angle here, right? And we have the side that is adjacent this acute angle next to this, that's BC. And the other thing that we're looking for is EC, which is the opposite side. So you have an adjacent and an opposite. So we're going to use tan here again. Okay, so tan. So next thing is we need to find this angle. We wouldn't need a calculator for that. That's fine. Do you see again? 122 is the exterior angle of this triangle. So the exterior angle is equal to the sum of the two opposite interior angles, meaning this angle plus 90 degrees gives you that. Meaning to find that angle, you say 122 degrees minus 90 degrees. Okay, and that's going to give you 32 degrees. So there, you can just tell them as well that angle CBE is equal to 32 degrees. Okay, so we have that down. And now that we know this is 32 degrees, this can help us to find EC. So this is the angle, that's the opposite, that's the adjacent side. So we're using tan. So tan of 32 degrees is equal to, the opposite side is EC, which is what we're looking for. The adjacent side is 8.3, which is BC. We don't have to call it BC, it's fine. Okay, so then we're going to make EC the subject. Okay, so to make EC the subject, multiply both sides by 8.3, 8.30. So that's going to give you EC is on its own now. But what happens when this multiplies here is it becomes the coefficient of tan. So 8.30 tan 32 degrees. And we just have to find this. Okay, so EC equals. So on your calculator, you can use ounce. I'm just going to say equal to, and I'm going to say 8.30, which is my answer, right? So I'm going to say ounce and then tan 32 degrees. And then just wait for it to get the answer. And that gives us 5 point, okay, so that rounds up to 9. And so that's 5.19 units, right, that we have. And now that we have EC, finding DE is very simple. Okay, so finding DE, because this is 5.19, do you see that the entire length of DC is 16 units, right? And you know that EC is 5.19. So CD minus EC finally gives you that length DE. Okay, so we're just going to say to find the length of DE, therefore DE is equal to 16 minus 5.19 units, which you really do not need answer for that. I'm just a little too careful sometimes. Okay, so it's equal to 16 minus our final answer. And that would just be our answer. And our answer is 10.81 units. And that is it. DE is equal to 10.81 units. And that is it for trigonometry for paper 2. And I will see you guys in Euclidean geometry.